Welcome to the project demonstration of live human being detection robots with controlling through IoT using ESP32 camera. So we can control this robot movements from the mobile phone, from the Google Chrome by accessing the IP address of this ESP32 camera. We can get the visuals and also robot controlling forward, backward, left, right, and headlights on and off. Along with that, the system has the two sensors with the three alerts. So in that one sensor is PIR, the passive infrared sensor, which can detect the passive rays emitting from the live human being, and when the passive rays detected, the system will trigger the nanoboard and the system will send the message alerts through this GSM modem. That particular message consists of location values in terms of latitude, longitude, and also humidity, temperature values, which are received from this DHT11 sensor. So the next two alerts are like humidity, high humidity. Whenever the humidity level is 75% above, it will send the message alert along with location and the parameter values, and temperature is above 40 degrees centigrade, it will send the same message alert. So here the main components are like 4 DC motors we are using. This vehicle is a 4-wheel drive, and that 4 DC motors interfaced to the ESP32 camera through this L293D motor driver. So we can control the 4 DC motors. In that, 2 DC motors are in parallel, these 2 are in parallel, and the voltage for these motors and the remaining other electronic components are getting from this 12 volt 1 amp battery. So as we can see that 3 4-volt 1 amp batteries are in series, so we will get 12 volt 1 amp. So that is the operating voltage for the DC motors. But the operating voltage for our ESP32 camera, GSM, GPS and nano are the 5 volts. So in order to regulate that 12 volts DC to 5 volts DC, we place the LM2596 voltage regulator. So from there we are getting the 5 volts DC output. So we are distributing the 5 volts power supply throughout this breadboard. So from here we are distributing that throughout the input and output modules. So coming to the interfacing connections, DHT11 interface at the pin number 11, and PIR sensor interface at the A0 pin of our nano board, and GSM module at pin number 8 and 9, GPS at pin number 10. So these are the interfacing connections here. And ESP32 camera is independent of nano board. Directly it will take the input from the browser and controlling the robots with help of this L293D motor driver. The connection between these two is pin number 10, 11, 12, 13 pins are connected to the ESP32 camera. Headlight is directly interfaced on board, LED is there on this ESP32 camera. So before on the gates, the main thing is we should keep this battery under fully charged. So for that purpose we have provided the battery charger. So connect the battery at this B slots and on the power supply for the transformer. So transformer will step down the 230 volts AC to 12 volts AC, and this regulator power supply board will convert that AC to pure DC voltage, and the charging time for this 6 hours minimum, 8 hours maximum, as we are using the timing based charger. So after that completion also in between, if it's before battery is fully charged in below 6 hours, then automatically this charging circuit will block the current flow in order to protect the battery from overcharging. So the next step is insert the valid SIM card into the GSM module. So there we need to insert the Airtel SIM card or VI SIM card, and it should have the main balance or message balance. And the next third step is go to hotspot settings of your phone. By using your hotspot settings only, the system will connect to your mobile phone. So for that purpose, change the hotspot name to PROJECT project 5873 without any space, without any capital letter. Password 129. AP band should be 2.4 gigahertz. After these 3 settings, now on the power supply, there should we see the right. We can see the ESP32 camera was connected. And the main thing is we need to cover this PIR sensor as well. We are demonstrating the sensor keep on detecting the human beings and it will stabilized. For that we can see one more indication, right? So coming to the indications, there we can see, I'll show you that. So when we on this initially, this particular green light will on and off at a duration of 1 second. On successful get the signal, if it is not showing on the mobile phone, just off it and on. Right, we connected, and now check this GSM model. The next step is, so it has to blink slowly. Till that, wait. When it's blinking rate is 3 seconds per blink. Now the GSM modem got the signal, and we can cover the PIR sensor kerchief, you know. The light is power status of nanobot. Another light beside of that will blinks 2 times once the stabilizer was done from the PIR sensor, and after that the 2 lights will blinks continuously as a loop execution. So meanwhile we can see the robot controlling section. So if some new mobile phones doesn't show this IP address, for that purpose you need to install the network analyzer application and open the application, go to options, do LAN scan. There we get the IP address. So copy that and now go to Google Chrome, paste over here. So now we are getting that streaming. Now we will cover that. Right. Okay. And meanwhile, before execution of the SMS section, check the controlling of your robots. So controlling, when you click and hold this forward button, the robot will move till that time. So as we are using the 4-wheel drive, the rotation is high precision along with headlight on and off. And once the PIR sensor got stabilized, we will get the message alerts to the registered mobile phone number that consists of location, right, we can see that. So these are parameters we will get along with, now we got the message now. So temperature and humidity in degrees centigrade, temperature humidity in percentage. So once the PIR sensor gets stabilized one, so there's a light indication, we can see that the second light is got on now, means now it's sending the message alerts. So we got the message now. So the same manner for humidity and temperature also. And one more main thing is, while we are demonstrating, we can see that 00 values over here. So why? Because we are executing this project under the roof, means there is no satellite vision for the robots to the GPS, so it won't get the live location values in terms of latitude longitude values. So while demonstration, if you place this under the roof, under the sky view, then based on the trial iteration method, the GPS will get the live location in terms of latitude longitude values, and that will be placed live location along with Google Maps link in our message.